Hello, everybody. Welcome to another episode of Just Enough Learning Online. So, today we are breaking down a powerful AI concept called a retrieval augmented generation, or simply called as RAG. But wait, we are not just talking about what RAG is, we are also diving into how RAG understands these data using techniques called chunking and vectorization. If this sounds too technical, don't worry. I promise that by the end of this video, even if you have never heard about AI before or never touched AI before, you will understand how RAG makes AI smarter and more accurate. So let's get started. All right, let's picture this. You ask an AI chatbot, what are the latest AI privacy laws? And it gives you an outdated answer. Why? Because most AI models like ChatGPT only know what they were trained on. They don't magically update themselves. So, if new laws were passed after the AI was trained, it has no clue. And that's not all. Sometimes AI do hallucinate and make up answers that sounds real, but they are not. And that's a big problem. So the question is, how do we fix it? That's where the retrieval augmented generation or RAG comes into picture. So a RAG solves this by retrieving external knowledge and augmenting the AI response with the most relevant information before answering. Think of it like an AI that can Google real-time data before giving you an answer instead of relying only on its memory. All right, let's move on to the next question. How exactly a RAG works? So, to simplify this answer, let's classify the RAG into three key steps. And this is exactly where the magic happens. The first step is retrieval. Assume a user asks a question to the AI. The first step is AI searches for the relevant real time information from an external knowledge source. This knowledge source can be in the form of a database, document, or even a website. And the next step is the augmentation. Now, AI is done pulling out the relevant real time information from the knowledge base. Now, the AI enhances its own understanding by mixing this retrieved information from step one with what it already knows. So this means the response isn't just a random data, but a smart combination of both stored knowledge and fresh facts. Now moving on to the next step, that's generation. Now the AI is done retrieving the information and augmenting it with what it already knows. The final step is AI generating an answer using this augmented knowledge, making sure the response is accurate, relevant, and up to date. To give a simple analogy, think of it like a student taking an open book exam. A regular AI model is like student answering from his memory. But a RAG powered AI, it's like a student who can check books, highlight key points, and combine what they find with what they already know to craft a perfect answer. Now that we know how RAG works, here is the big question. Where does the AI get this fresh data from? Well, I must say it's not magic. AI needs a structured way to find, store, and retrieve relevant information efficiently. And that's where the concepts of chunking and vectorization comes into picture. Imagine an organization's data is like a giant library. If AI has to find useful information, it can't just read every book page by page. It needs a way to organize and search through the data quickly. That's exactly what chunking and vectorization helps with. So let's deep dive a bit into the concepts of chunking and vectorization. So first up, chunking. Before AI can retrieve the information, the data must be broken down into small, manageable pieces called chunks. Instead of storing full documents, we actually split them into smaller sections that make searching much faster and more precise. Now, why is it that important? Because when you ask AI, let's take an example, what is your company's refund policy? It does not need the entire page policy manual. It just needs the right chunk of text. So that's why chunking is so important in the RAG architecture. Now moving on to the next part, that is vectorization. Now that we have broken data into chunks, how does AI find the right chunk? Enter the concept of vectorization. Instead of searching by keywords like Google, AI converts each chunk into vectors, which is a mathematical representation of the text. And these vectors are stored in a database. And when you ask a question, the AI compares your query's vector with stored vectors to find the best match. It's like using Google Images, but instead of searching for pictures, AI searches for meanings. Now we understood a lot of concepts in the previous couple of sections. Now let's try to put it all together. And this helps you understand the full RAG process and how exactly it works. So the first step is data ingestion. In data ingestion, the documents are broken into chunks and turned into vectors. And the next step is AI retrieval. So when you ask a question, AI finds the best matching vectors. The third step is augmentation. Now AI mixes this retrieved data with its own knowledge. Step 4, that's AI generation. AI creates a fact-based, up-to-date response. And step 5, you get a smart, accurate answer. Now the final question, why should you care? Now, RAG is everywhere these days. Most of the organizations have already adapted RAG into most of their solutions, be it in the form of chatbots and customer support, or legal and compliance related use cases, or even in that matter of healthcare and researchers. We can find a RAG everywhere. So understanding how RAG works and how RAG is being utilized by these organizations are so much important in these days. And RAG is the future of AI powered knowledge systems. There is no doubt about that. So let's sum it up. RAG stands for Retrieval Augmented Generation. Chunking is a concept where you split data into searchable sections, and vectorization turns text into searchable math. And that's how AI gets smarter, faster, and more accurate. So if you have any questions, drop them in the comments. And if this helped you understand RAG, give this video a like, share, and follow for more Just Enough Learning online contents. See you next time.